Hello students, welcome to Inside Physics. I am Srinivas. Today we are going to discuss about the motion of a particle at a turning. So we all experience when we are going in a vehicle, we are going in a straight line and suddenly there is a turning. So we experience some different kind of movement in a turning while moving with some low speed or some higher speed. So depending on our speed, we will be moving in a turning and we will experience some forces at the time of taking a turn. So we will see how it goes. Motion of an object at a turn. First case, here we will see the motion of an object on a rough horizontal road or on a rough level road. Rough means there will be some friction on the road and a vehicle is moving on the road. When it is at a turning, so what are the forces acting on it and what is the velocity on that particular turning so that it will not fall away from the turning. Generally we see when an object is in a turn or in a curved path, so there will be a radius of curvature. That means if the curve is extended as a circle, the center of the circle is having a distance from the particular curve, and this is called the radius of curvature or the distance from the center of the circle to the curve. So here when a particle is in moving in a curve, we know a centripetal force will act on the object towards the center of the circle, and to balance that force so that in circular motion the object will not fall into the center, a balancing force called centrifugal force will act on the object in exactly opposite direction and that equal and opposite. If this is the centripetal force acting on an object moving in a curve, and this will be acting towards the center of the curvature, an exactly equal and opposite force will be acting quite opposite to the centripetal force, which is called centrifugal force. That is why, so the balancing force is there and both are equal, then the object will move in circular motion without falling into the center or it is going away from the curve. So this study where related to some circular motion also will be having this concept applied to a object or a vehicle moving on a rough horizontal road. So we will see what are the things here we need to observe. Suppose I will take a car moving on a horizontal road and the weight of this vehicle will be acting downwards, okay, and in the same way the normal reaction will be opposite to that weight and opposite to the perpendicular to the surface, that will be same as mg, and the normal reaction here n is equal to, we will write it as mg, okay. So when it is a horizontal level road without any angle of inclination, so there will be, it is moving in a curve, so there will be a static friction here, which is the coefficient will be mu s. So here the static friction will take between the surface and the tires of the vehicle. So the force, the frictional force, static frictional force will be mu s normal reaction, that is mu s mg, okay. This mu s mg will be equal to the centrifugal force. Actually, this is the force which acts as centripetal force for a vehicle moving in a curve. Suppose the road is like this. The vehicle is moving like this. So this frictional force, static friction, we will consider. Even though the car is moving, we need not consider the kinetic friction, because see, the direction in which the centripetal force is acting is towards the center of the circle. That is why we consider the static friction also, because the motion is perpendicular to the centripetal force. So this is the force which we can consider as centripetal force acting towards the center of the curve, and this is balanced by the centrifugal force, and we can equate these two. We can cancel m, and so that we can write mu sg is equal to v square by r. So with this, what we can do is, if you want to calculate the velocity, so here the maximum velocity, so that it will not fall away from the curve, we can write the velocity here is v square is equal to mu s rg. So this implies v is equal to root of mu s rg. So this is the velocity where a vehicle moving in a rough level road must have a turning without falling away or without falling inside the turning. There is no banking, that means the road is level. So the only possibility, if the vehicle is exceeding this velocity, is falling away from the curve. So that is how we can measure the velocity on a level road at a turning. For this, if you know the velocity of the, if you fix the velocity of the vehicle, suppose at this particular turn, we can see when we are going on highways, the speed limits will be set. Like on the left side, that 60, 80, 90, that numbers, what are those numbers? The speed limits are set for that particular situation or particular instant of that road. Well, if you cross that place, you may have the excess speed limit or lower speed limit, but at that particular junction of the road where some turnings or some junctions are there, then you can have a speed limit, you can fix the limit, and by fixing the limit, you can calculate the radius here, radius of curvature. So what can be the turning and what can be the amount of turning you can put to the road while laying the roads. So this is the concept of rough horizontal road and a vehicle moving on the road with some turning. So we'll take up the case 2. What is case 2 means? Here the road will not be a level road, it is a banked road. That means that an inclined road. So if we see, suppose this is a level road and we can have an inclination like this for the road. See, why we should have an inclination means the banking, this is called banking of roads. If it is a level road, it will be like this. At turnings, suppose this is a left turning like this, the road will be, the outer level will be raised with respect to the inner level by some angle theta. This is called angle of banking. Theta is called angle of banking. And the raising of the outer level compared to the inner level of roads is called banking of roads. So what is the advantage by having this kind of inclination at the turnings? So you can make the vehicles go safer so that they will not fall away. So with this inclination, there is a balance in the inner pulling centripetal force and frictional force, and the outer force like centrifugal force. So you can easily have a higher speed limit so that the vehicles will not be slowed down very much, so they can go at a reasonable speed without going falling away. Okay, that is the advantage of banking of roads. See, we see here what happens on a smooth inclined road. Smooth inclined road. Smooth means we don't consider the frictional force there. So I'll draw a vehicle which is going on a turning like this. Okay, so here if you observe, the weight of the body is downwards, so the normal reaction will be like this, and this, see, if you draw the components of normal reaction, so this will be n cos theta and this will be n sin theta. Okay, so if we consider this as a smooth inclined road, there will not be any friction. We need not consider any frictional force between the tires and the road. So here if you observe, mg is equal to n cos theta, and the n sin theta will make this equal to the centrifugal force which is acting on the vehicle, and this n sin theta, so component of normal reaction acting left side toward the center of curvature will be balancing the centrifugal force, and this is also acting like centripetal force. Now we'll make the equations here. The first one, n sin theta is equal to mv square by r. Why we are making this equal means, see, if this is more than this, then the vehicle will be start sliding down the plane, and if this is more than n sin theta, then the vehicle will fall away on the, even it is an inclined plane. So for this, the balancing condition to go on turning without slipping or without falling away is mean that we can equate these things. So n cos theta is equal to mg. N cos theta is equal to mg. So this is equation 1, this is equation 2. If we divide equation 1 with equation 2, we see what happens. I can directly write this is tan theta is equal to nn will gets cancelled, sin theta by cos theta is equal to tan theta, and mv square by r by mg, that means mm gets cancelled, this will become v square by rg. Okay, v square by rg. So to know the velocity, this may become tan theta or g. That implies v is equal to root of tan theta or g. So here also we have find out the formula for the velocity for a vehicle going on in a turning on an inclined road where the angle of inclination, angle of banking is theta. So here tan theta into radius of curvature into gravity value. So this is how we find out the velocity limit to go for a vehicle without slipping away or without falling away. So this is the velocity limit, and we also discussed how to get the radius. If we set a limit velocity for a vehicle, and you can also have the radius of curvature, how much you need to set the radius of curvature. You can have this formula used by some people who are laying the roads, like some contractors. So they will may know the radius or the velocity limits by using these formulas. This is on smooth inclined road. The third case, that will be a rough inclined road. So we'll change smooth to rough. Rough inclined road. So the same will be applied here, but the only difference is here the friction will be taking part in our calculations. So how to consider the friction? So we have already discussed that the static friction will be the consideration here, and the friction will be between the tires and the road. So we can have the friction here. What is the direction of the friction? If we consider the direction of the friction like here F, and here also we'll make the components of friction like this. F here is the frictional force, and I draw a normal to F cos theta, that means F sin theta. So this is the frictional force where the inclined plane is like this, and the frictional static friction will be acting towards the center of curvature like this component of normal reaction. So these two will act in the same direction, and this will be the centrifugal force in the opposite direction. So here see, when we consider the F cos theta, that means see force, frictional force is nothing but mu s, right, mu n. So if we replace this F cos theta with mu n, we can write the substitute in the formulas, and we will get the equations for the velocity limits. Okay, we will see how we need to take. So this 2 n sin theta plus F cos theta is mv square by r. So n cos theta is equal to mg. Okay, so in case 1, so this is the case where the object is moving on an inclined plane, on a rough inclined plane. So here we are calculating the velocity limits for that. Okay, here we may observe two cases. What are the two cases we may observe? Case A. Okay, if n sin theta less than mv square by r, that means mv square by r greater than n sin theta. Okay, see here, now we equate these equations, how it goes. Look at that, n sin theta less than means the centrifugal force is more. So here can write n sin theta plus F cos theta means mu s n cos theta is equal to mv square by r. See why? Because see, this is the normal reaction component acting towards the center, and this is the static friction component acting towards the center. So what are the two forces acting towards the center? These two. So these two are added because in the same direction they are acting, and they are actually of the same object. Now if you consider this normal thing, what we can write here? So this is the frictional component. Okay, so n cos theta minus mu s n sin theta is equal to what? Here it is equal to mg. Previously it is not like that. Now the frictional force is also taking part, right? Normal reaction is, this component is upwards, so this component is downwards. So we have subtracted this one. So we have got the value as n cos theta minus mu s n sin theta is equal to mg. So this is equation 1, this is equation 2. Okay. So we will divide with equation 1 with equation 2. So here if you observe, I will divide this one with sin theta. Then what happens? So if I divide equation with sin theta, this becomes n plus mu s n, this cos theta, and this is okay. I will divide this one with cos theta. So this becomes equation 1. I am dividing with cos theta. This will become n tan theta is equal to mu s n is equal to mv square by r. So cos theta. Okay. So again I am dividing this equation with cos theta. Then it becomes n minus mu s n tan theta is equal to mg by cos theta. So here I have done, see what I have done, I will explain you. For equation 1 I have divided LHS and RHS with cos theta. So it has transformed into this equation. I divided equation 2 with cos theta again, and it has become n minus mu sn tan theta. Sin theta by cos theta will be tan theta, and this is mg cos theta. Okay. So this is equation 3 and equation 4. If I equate, that means, see, if I divide equation 3 with equation 4, we will see what happens. So I am dividing equation 3 with equation 4. That implies, so I can cancel this n also. N I will take it out, tan theta plus mu s is equal by n into 1 minus mu s tan theta, okay, is equal to, so mv square by r cos theta, mv square by r cos theta by mg by cos theta. Okay. So from here I will write in the beginning. So we can remove this. So observe from here. So nn gets cancelled, this n gets be cancelled, and tan theta plus mu s by 1 minus mu s tan theta is equal to, see, cos theta gets cancelled, gets cancelled. So what I get here, observe, cos theta will be getting cancelled, is also getting cancelled. So I can write v square by rg. Okay. So with this equation, if you observe, you can transform the terms, and with this you can get this rg into tan theta plus mu s by 1 minus mu s tan theta. So here you have got v square, so you can find the v, so by taking the root, v is equal to root of tan theta plus mu s rg by 1 minus mu s tan theta. So this is the equation for velocity on a rough inclined plane when the object is moving in a turn by considering the horizontal friction, that is static friction. Okay, so this is case 1. Now we will observe what is case 2. What could be the case 2? In first we have taken n sin theta is less than mv square by r, that is case 1, that is what we have dealt here. In case 2 we will take up n sin theta is greater than mv square by r. Okay, this is, you can call it as, see, in the case A, you can carry it as this V maximum. That means, see, when n sin theta is less than mv square by r, the maximum velocity, so that it will go safely, that means it will not fall away, because mv square by r is more than n sin theta. So we can call it as V max. In the second case, case B, where n sin theta is greater than mv square by r, that is, the vehicle may have a chance of sliding down the inclined plane, okay, when n sin theta is greater than mv square by r. So in this case, we will equate the terms here again. What is the equations? We will observe here. N sin theta, that means n is nothing but normal reaction, we have taken capital N. N sin theta minus mu s n cos theta is equal to mv square by r. Okay, why I have taken like this is n sin theta is greater than mv square by r. So to equate, to balance this, we need to subtract the frictional force, because the horizontal component of normal reaction is more. Okay, now we will equate the vertical terms. Now here n cos theta minus the vertical component of frictional force mu s n sin theta is equal to mg. Okay, so in this case also we will follow the same procedure what we have done in case A. So the equation 1 is divided with cos theta, and again the same equation 2 is also divided with cos theta. What we will get? N tan theta, the equation 1 will be changing like n tan theta mu s n is equal to mv square by r cos theta, equation 3. So the equation 2 is also divided with cos theta, then it becomes n minus mu s n tan theta is equal to mg by cos theta. Okay, this is considered as 4. Again we will divide equation 3 with 4, then we will get some terms exchanged. We can get the velocity in the same way what we have done in case A. You observe, this is divided by the fourth one. Again I can take the n as common factor, tan theta minus mu s by n into 1 minus mu s tan theta. Okay, so I have taken the n common out, and the right hand side terms are taken. Cos theta anyway we can cancel, and we can directly write as mv square by r by mg, or mv square by r by mg, that means it becomes mg. So mm gets cancelled. So from this what we will get, I will write in the beginning. So n gets cancelled, mm gets cancelled. So tan theta minus mu s by 1 minus mu s tan theta is equal to v square by rg. V square by rg. So here we have got the same formula, not exactly same, but similar kind of formula in case A. Now we can write V square is equal to, so rg into tan theta minus mu s by 1 minus mu s tan theta. Okay, so if you can remove the square here, you can put a square root here, so we can do that. So this is the formula for the velocity where n sin theta is greater than mv square by r. So if it is greater, the horizontal component of normal reaction, there is every chance of vehicle sliding down the inclined plane. So it should maintain a minimum velocity so that it is not falling down the inclined plane. So we can put it as V minimum. So the minimum velocity required to maintain so that the vehicle will be moving in a turning without slipping down, because n sin theta is more in the case B. So in case A, what we have done, mv square by r is more, so that we have put a maximum limit for the velocity so that it will not fall away. That means maximum limit means it should not cross that limit. So V minimum means it should not be less than this V minimum, so that it should not be falling down the inclined plane. So V maximum, V minimum, those are the limits we will set while the vehicle is moving in a turning on a rough inclined road. So this is the concept of motion when the vehicles are moving at a curved road. Okay, so here this is the concept, and in further concept we will see some more topics of motion where we can find the concept of force involved in all the topics. Okay, thank you.